We are moving on to chapter 8. All right, so we're talking about polynomials, binomials, trinomials, all those things. But the first thing you needed to remember is what a monomial is. And we talked about this in chapter 7. But a monomial is any constant variable or product of the two. Okay, so things that are binomial or monomials are going to be like 2x, 2, x to the 5th is 4 over 2 times x is. This is not. The variable cannot be in the bottom, okay? It cannot be on the denominator, okay? So you have to have the variable up top. Okay, all a polynomial is, poly is a prefix meaning many, so a polynomial is just some number of monomials. And just so we're clear, a monomial is a polynomial. It's just one, but it's some number of monomials. And if that number it's just one, it's still a polynomial. Okay? A binomial, these is you use the prefix here. Bi means two monomials together. Okay, and I should say these are being added. Okay, a trinomial, this is going to be 3 monomials being added. Okay, so that's what those things are. The next thing you're going to need to know is what the degree of a monomial is. And the degree of a monomial is the sum of the degrees within the monomial. Okay, so an example of this. Okay, if I have 2ab, this variable and this variable would both have an exponent of 1. Whether we write it there or not, they both have an exponent of 1. Okay, so the degree of this doesn't have a variable. The 2 has a variable of it doesn't have one. It doesn't have a degree with it, so we just don't write it. It's 0, okay? So the degree here is 2. 1 plus 1. We're only concerned about the variables. That's a better way of saying that. We're only concerned about the variables when we're talking about a degree. The degree of a polynomial is the degree I don't know how to write this. The degree of the monomial with the largest degree. Okay, and that'll make more sense as we look at example 1. Okay, so in example 1, they broke it up into this table for us. Okay, so we have these expressions here, and they said, tell me if it's a polynomial. So that's the first section. Tell me what the degree is of the polynomial, and then to determine if it's a monomial, binomial, or trinomial. So those are our 3 sections of our table. So this is my expression, 4y minus 5. That is a polynomial. I know I said it's broken up with addition and this is subtraction, but that's the same as saying 4y plus -5. Okay, so it's fine. It's still a sum. It's still addition. All right, the degree is 1. Okay, this monomial doesn't have an exponent, so its degree is 0. This monomial has one exponent, or it has one variable with an exponent, so its degree is 1. It takes the degree of the larger of the two, so it gets the 1 as its degree for this polynomial. -6.5. This is a monomial. It is a polynomial, okay? Ouch. -6.5 is a real number. That's all it requires to be a polynomial. It just needs to be a real number. The degree of this, you have no variable at all. So if we have no variable, that means our degree is 0. Okay? This is a monomial because there's only one part to it. Right? And C, this is not going to be a monomial. Or it's not going to be a polynomial because it's not a monomial. Because 7a to the -3 would be the same as 7 divided by a cubed. The a is on the bottom. Bad, can't happen. This is not a monomial. So it can't be a polynomial. And then the last one, we have 6x cubed plus 4x plus x plus 3. Okay? See how they did this here? We had to combine some like terms to simplify this. So 6x cubed, they needed to put these two together to make it 5x plus 3. Okay? That's just because you can't find the degree and you can't find what type of polynomial it is until it's written as in simplest form. Okay, so I had to write this in simplest form first. That's what I did here. The largest degree monomial inside this polynomial is 3, so it got a degree of 3 on it. And then it's a trinomial because it has 1, 2, 3 monomials within it. Okay? All right, so take a quick pause and try 1a through 1c. Okay, so for 1a, you should have got, yes, this is a polynomial. It has a degree of 1, and it is a monomial. There's only one portion to it. For 1b, I had to simplify this here. Okay, the -2y plus 4 became plus 2y. So I had to simplify that into one term, but I did, and I got that. Yes, this is a polynomial. The degree of it is 2, and it is a trinomial. Okay? For 1c, you need to have that this is a binomial, or it is a polynomial, I'm sorry. The biggest degree is 3. I found that by taking each monomial within it. The degree of this one is 1 plus 1, which is 2. The degree of the second one is 1 plus 1 plus 1, which was 3. So the degree of this would be 3. And then it has 2 portions, so it's a binomial. And then this one is not a polynomial because of this here. This is 10 over x to the 4th, which is not a monomial, so it's not a polynomial. Okay? All right, so let's look at standard form. And all this is the polynomial written with exponents in descending order. Okay, so if you look at A here, in example 2, we have 3x squared plus 4x to the 5th minus 7x. It wants us to write this in standard form and then identify the leading coefficient. Okay, So to do that, I need to technically write everything as addition, because addition is commutative. That means I can move things around. So I'm going to pull my 4x to the 5th out front because it has the largest exponent. And then I'm going to put 3x squared, and then I'm going to leave the plus 7x. Okay, so now my exponents are, or plus negative 7x, I'm sorry. Now my exponents are in descending order. 5 is the largest, 1 is the smallest. I need to simplify this. So 4x to the 5th plus 3x squared minus 7. Okay, identify the leading coefficient. My leading coefficient is 4. So that would be my answer. On B, same idea. Okay, rewrite it all as addition so that you can move things around and get the exponents in the correct order. Okay, my largest exponent here is the negative 2y to the 4th. The 4 is the largest exponent, so negative 2y to the 4th is going to come up front. After that, I have a third, so I'm going to go plus negative 6y to the 3rd. And then my next exponent is just a y to the 1, so I'm going to have plus 5y. And then the last thing I have is plus negative 9. Okay? I'm going to rewrite this without all my double signs. So I have negative 2y minus to the 4th, minus 6y to the 3rd, plus 5y minus 9. Okay? Now also, for anything to be in standard form, your leading coefficient can't be negative. Okay, so that means I have to come over here and I have to basically multiply all of this by negative 1 so that I can make this number positive. So this is going to become 2y to the 4th plus 6y cubed minus 5y plus 9. And my leading coefficient is 2. Alright. Try 2a and 2b. Alright, so for 2a and 2b, for 2a, you should have gotten 4x needed to come out front, and then negative 2x squared came next, and then a negative 3x, and then it was a positive 8. Made a little mistake there. So it should be plus 8 on the end. My leading coefficient was 4. On this one, I originally got my leading coefficient to be negative 7y to the 6th. That was my largest exponent. After that was 5y to the 3rd. And then negative 2y squared plus y plus 10. I needed to make sure my leading coefficient is positive, so I went through and changed the sign of everything, and I end up with 7. Okay? As my leading coefficient, I should say. All right, so then example 3 and A and B, we're talking about adding. We're going to start putting polynomials together. So we have like 2 polynomials, and we want to add them together. So here's my first polynomial. Here's my second one. All you need to do is, well, first off, all these little parentheses, they're not actually needed. They're just telling you this is the first polynomial, here's the second one. But we don't actually need them. So we can rewrite this without the parentheses. And I'm also going to, as I'm doing that, I'm going to change everything to addition as I do that. So it's going to be plus negative 7, plus 3, plus negative 4x squared, plus 6x. Okay? All you need to do now is we rewrote everything as addition so that we can get all of our like terms next to each other. So I have 2x squared plus negative 4x squared. That's a like term. Like terms have the same, they have the same exponent and variable. Okay, so you get all your like terms beside each other. So those two are taken care of. And then my next one I have is a 5x, and it has a like term of 6x. And then I have -7 and 3. Okay, now I have everything matched up with its like terms, so I'm going to add them. Okay, so 2x plus -4x squared, this will become -2x squared. You add the coefficients and keep the variable. Plus 5x plus 6x becomes 5 plus 6 is 11x. Plus -7 plus 3 would be -4. Okay? Make sure you simplify this, and you need to make your leading coefficient positive, so multiply it by -1. So 2x squared minus 11x plus 4 would be our answer. Okay, so this is what we call the horizontal method, because we do exactly that. We add horizontally. The vertical method, same idea, except sometimes you have to put in placeholders, but it still works. Okay, you can use whichever one you want. I genuinely don't mind either. I just like the horizontal method, but you will be able to do whichever you like. Okay, but when you use the vertical method, always start with the longer of the two polynomials on top. Okay, so I'm going to do this one in red. So when you do the vertical method, make sure the longer of the two is the top polynomial. So I'm going to put 4y squared plus 4y, -4y, plus 2y cubed plus 8. Okay, and before I even do that, I'm going to put this, I'm going to erase that. I'm going to put this in standard form. Okay, so I'm going to take 2y cubed. That is my largest one, so I'm going to put that out front. And then I'm going to write 4y squared. That's my next one. And then I have a -4y, and then I have 8. So I just rewrote it in standard form. The next one I'm going to do is underneath, I'm going to say, I'm going to add the other polynomial. Okay, and again, I'm going to put this in standard form. I'm going to put the leading or the largest exponent in front. So y to the third. Plus, I don't have a y squared in this one, so I'm not really adding anything here, so I'm just putting 0 as a placeholder. Plus, I do have a y term to match up here, and I do have a constant to match up here. All right, so add these things together. 2y cubed plus y cubed gives me 3y cubed, plus this becomes just 4y squared, minus -4y plus 3y becomes -y, and then 8 plus -5 becomes +3, and there would be your answer. All right. Just try 3b. If you can do 3b, that means you can handle 3a, and then check back in to see if you get it correct. Okay, so for this one, you should have taken, all I did is like I said, I like the horizontal method, so I matched up my like terms. I had a -2y cubed and a -2y to the fourth and a y to the fourth, so I put those in a set of parentheses together. The 2y cubed was alone. It was the only cubed variable, so I just stuck it there by itself. And then I had two y terms, so they went in a set of parentheses together, 2y and -3y. And then my two constants went in a set of parentheses together. Okay, I combined those and I got -y to the fourth plus 2y cubed plus -y plus -4. I multiplied everything by -1 to make sure that was positive, and ended up with y to the fourth minus 2y cubed plus y plus 4. Okay. All right. when we're talking about subtraction, it's the same kind of concept here. Nothing too tricky. The only difference is you have one more step before you can add them. Okay, so the adding process doesn't change. You just have one step you have to do before that. Okay, because basically you have a -1 out here. So what this really means is 3 minus 2x plus 2x squared plus -1 times 4x minus 5 plus 3x squared. So what we need to do is distribute this -1 into our parentheses, okay? So this is going to become 3 minus 2x plus 2x squared. That hasn't changed. Plus -4x plus 5 minus 3x squared. Okay, now you can go match up your like terms. Put your biggest exponent, or your leading exponent in the front from the beginning. So I'm going to have 2x squared as my biggest exponent, and it matches up with -3x squared. Those are gone. And then I have a -2x and a -4x. Those are gone. Then I have a 5 or a 3 and a 5, and those get added. All right. All you do from here is simplify it down. So you end up with 2x squared. Well, that's a lie. 2x squared plus -3x squared, which would give you -x squared. Then you have plus -2x plus -4, which is -6x, plus 3 plus 5 is 8. Okay. Multiply by your -1, x squared plus 6x minus 8 is our answer. Okay, try guided practice 4 and see if you get it right. Okay, for our last one here, I distributed in my negative to each term, changing the second half to 2x cubed minus x squared plus 2. Matched up my x cubed, matched up my x squareds, and matched up my x's. There was only one of them, so it kind of just hung out. And then I matched up my constants. It left me with 6x cubed plus a negative, and then I had a plus negative over here. So my last step was to just get rid of those double signs, leaving me with 6x cubed minus 4x squared plus 6x minus 2. Okay. The homework is posted. Please reach out if you have any questions.